And then Chelsea, what do we do with the square root of 18 then?
The square root of 9 times the square root of 2.
Which is?
3 times the square root of 2.
Right. And we did that last chapter. Again, we're just reviewing it to make sure everybody's okay with those properties, but we use this in completing the square. We use square roots in the quadratic formula. We use square roots when we were solving. When you're factoring even, you might end up with a square root if you're solving for something that has x squared in it. So the quotient property is exactly the same, but it's a division instead of a multiplication. So you're looking at them separate, taking the square root of a divided by the square root of b. So if we had the square root of 2 divided by the square root of 25, Ethan, what would that become?
Square root of 2 over 5.
Yep, square root of 2 over 5. So if we can change the number because it's a perfect square, then we would want to do that. So in the middle of the page, it talks about simplifying square roots. So if a square root is simplified, it has to meet both of these little bullets. So a square root is simplified if the radicand, which is the number underneath, has a perfect square factor, or doesn't have a perfect square factor other than the value of 1. So what that's saying is it can't be broken down any further because there's not a perfect square left underneath the square root. So the square root of 3 is broken down all the way because you can't change the square root of 3. You can't change the 3. The other reason it has to be simplified is that you can't have a radical in the denominator. So we can't have like 1 divided by the square root of 2 because that's considered an unsimplified fraction. So that kind of look at the next 3 problems here. These are pretty easy problems that we've already talked about. Cooper, the square root of 24 can be written as?
2 square roots of 6.
Yeah, 2 square roots of 6. Because it's the square root of 4, the square root of 6. So that's 2 square roots of 6. What would we do with letter B? So the square root of 5 times the square root of 18. What would you do with that? Zach, what do you think?
Oh, okay. Well, what I did was I split 18 and the square root of 9 times the square root of 2. And then I got 3 times the square root of 2, and then I multiplied the square root of 5 to get 3 times the square root of 10.
Good. So he broke 18 down into 3 square roots of 2, and then you still have this square root of 5. So he said he had 3 square roots of 10. Nice job. So break the 18 down, and then continue to keep the square root of 5, the square root of 2, multiply those together. Letter C, we have the square root of 9/64. So what does that become, Julia?
It becomes 3's.
Yep, 3/8. You can break that down, they're both perfect squares, you get 3/8. Questions? So the other part that we're going to talk about, which would be the newer part, would be taking a number that is the square root of 5 over 2, which really is the square root of 5 and the square root of 2, and trying to simplify it. Now, we did part of this already. It says the denominator is not a perfect square, but in order for it to be simplified, we can't have the square root in the denominator. So we have to do something with it. A 102, so it's like in the corner over there. Okay. So what would you do to this problem, Brandon?
You multiply the top and bottom by the square root of 2, so you have the square root of 10 over 2.
Right, so our goal is to get rid of the square root that's in the bottom. And when we did problems like this, to get rid of that square root that was in the bottom, we multiply it by the same square root. So there was a square root of 2 down there, so we multiplied the top and bottom by the square root of 2. Do you know what that's called, Brandon? That process has a name. Chelsea?
Isn't it like rationalizing the denominator?
Terminated.
So it is rationalizing the denominator.
I like Terminator better.
Yeah? So to get the square root out, the process is called rationalizing the denominator.
Good job, Joyce.
So multiplying it by the square root of 2. Then the top number, it becomes bigger, yes, but that's okay. We got the square root of 10, and now the whole number on the bottom is what we're looking for. So the new part comes in the chart below, because now there are going to be 3 cases that we're going to look at that could happen with denominators. So not every denominator is just going to have one number on the bottom, because there are other cases that we could have extra parts in the denominator. So the part on the left says what the denominator currently has. The part on the right is what you would multiply the denominator by to get rid of the square root, because that's our ultimate goal. We want to get rid of the square root. So the first one is exactly like we just dealt with. So the square root of b would be any number. B is any number. So if it was the square root of 2, we'd multiply by the square root of 2 to get rid of it.
That's easy.
So that's what we've done before. However, the other 2 add an extra value with it. So what happens if we have a plus the square root of b, or like 3 plus the square root of 2? So now we have that extra number in there that's being added with the square root. And I can't just simply multiply by a square root of 2 to get rid of it because of the extra number in the problem. So the way that we end up getting rid of it is by multiplying by the opposite factor. So if we have a plus the square root of 2, the opposite would be 3 minus the square root of 2. So it's that middle sign that's going to change. By changing that middle sign, we're going to see that things cancel out. So think of like when we did the factoring or the foiling and we multiplied x plus 2 times x minus 2. When we multiplied those together, what happened? So if we multiply x plus 2 times x minus 2 together, what happens when you multiply them together? Brandon?
The middle term gets canceled.
Yeah, the middle term gets canceled because we'd have x squared and then a negative 2x and a positive 2x. And then these guys make a positive 4. But that middle term cancels because of that plus and minus. So that's our goal, to get that middle term to cancel by multiplying with a plus and then a minus. So the same thing would happen if we had 3 minus the square root of 2. We would then multiply the denominator by 3 plus the square root of 2. So the key thing to remember is always multiply by the opposite sign. So you should always have a plus and a minus when you're multiplying so that hopefully pieces will cancel. So on the back page, there's only 4 examples. Like this is it. As I said, like just a little bit of notes, a little bit of problems to kind of look at and go over. The first one is something we've already done, where we have the square root of 7 divided by 3, which is really the square root of 7, the square root of 3. So this is just the one number case. You've got one number in the denominator. So if we want to get it out of the denominator, we need to multiply by just that number, the square root of 3. So Nina, what would the top become?
The square root of 21.
And the bottom is? 3. So Nina, can I take the square root of 21 and divide it by a whole number of 3 to reduce it?
Yes. No.
What do you think? Yes? No? Maybe so.
Yes. No.
Maybe.
No.
No. A square root is different than a whole number.
We don't know if the square root of 21 is divisible by 3.
So you can't really divide it by 3 unless you actually calculated the square root of 21, you got a decimal, and then you divided it by 3. So you can't just simply say, oh look, it should be the square root of 7. They're different types of numbers. Their values are different. So this is it. You can't simplify it any further. You're done with the problem.
If that
So
would have
it's-
been the question, it would have been
Wait.
different.
Ah. So the square root of 21 divided by whole number 3, different kinds of numbers. You can't actually reduce them. So if you look at letter B is now the new type of problem with this extra part in the denominator. So we have 5 plus the square root of 3 in the bottom. What would we multiply by to get rid of it?
5 minus the square root of 3.
Right, so we're going to multiply by 5 minus the square root of 3. And whatever you do to the bottom, you have to have that same quantity on the top. So 5 minus the square root of 3. Now, because there are 2 terms there, no longer is it just one piece. We now have 2 terms. We need to think of this as a group. They're put together, they're grouped together. And when it's a group or multiple terms, you have to have parentheses around those. Because if I'm multiplying, I need to multiply all of the parts, not just the two parts that happen to be sitting next to each other. So the top number is a 4. How do you actually multiply it with the numbers that are in the parentheses? What would you do there? Grant?
Multiply the 5 by 4 and did the square root of 3 by 4.
So what's that called, Broden?
Distributing?
Yeah, so we're going to distribute the 4 through the parentheses. So 4 times 5 is 20. And then this part's a little weird. We're taking 4 times negative square root of 3. So how do you write that? Because it's more writing than actually multiplying. How would it get written?
Would there be an I in there?
No I.
Okay. Minus 4 times the square root.
Yeah, so you write the sign first. So it's a negative in front of the square root of 3. So I have a negative in front. And then we have the 4 and then the square root of 3. When numbers are written next to each other, that means multiplication. So if I'm multiplying 4 times the square root of 3, well, writing things next to each other also means times or multiplication. So we are multiplying these. We physically can't do the multiplication because you have, again, a number outside the square root, a number inside, but you still write them next to each other. Any questions with the top part? Can you subtract these? Can I take 20 minus 4 square roots of 3 and get 16 square roots of 3? No. Again, whole number, number with square root. They have to be exactly the same in order to combine them together. So this 20 is not a like term with 4 square roots of 3. So they must be the same numbers in order to combine them. So it just stays like that, 20 and then minus 4 square roots of 3. A lot of rules with numbers, especially square roots. All right, so now when we go to the bottom, how would you multiply these bottom 2 pieces together? So what's it called that you would use to multiply those together?
Foiling.
Foiling, yeah.
Foil.
So we're going to foil these because you have 2 things multiplying by 2 other pieces. So 5 times 5 is 25. And then we're going to take 5 times negative square root of 3. So write the negative sign first, the whole number, and then the square root. So negative 5 square root of 3. And then we have a square root of 3 times 5. It's positive 5 square root of 3. And then the last one. What's square root of 3 times negative square root of 3? What's that become?
20.
Yeah, what kind of 3?
Just the root
Positive or negative?
of 3. Positive.
If I have a positive times a negative, it's going to be a negative.
Sorry.
That's all right.
I wrote that.
So when you are multiplying, remember the whole goal of multiplying square roots is so that the square root cancels. So the square root of 3 times the square root of 3 is just 3. But my signs are opposite, so a positive and a negative. We have to make sure we got that negative down there. So our goal is to get rid of the square roots, but there's still square roots in the problem. Brandon, what happens with them?
They cancel out and you get, and on the bottom it's 22.
Yeah, they cancel. That's the reason we're doing this multiplying by a plus and a minus. The goal is to get those middle pieces to cancel so that we don't have square roots left in the problem. And then the top has a 20 minus 4 square root of 3. All right, so there are 3 regular numbers up here. We have a 20, a negative 4, and a 22. They're all the same type of numbers. What are they all divisible by?
2.
2. So we can actually divide them because they are all whole numbers. So we're allowed to divide all of them. So Nina, 20 divided by 2 is?
10.
4 divided by 2,
2.
and 22 divided by 2 is
11.
11. So I didn't divide the square root, divided the numbers outside of the square root because they're all the same. They're all like terms. Questions?
Is that the final answer?
That's the final answer. So if you look at letter C, it is pretty much the same, just the numbers are different. So see if you can try and multiply by the opposite of what's in the denominator. So if there's a minus, we want to multiply by the plus. parentheses go around all of those pieces. So then we're multiplying all parts of the
Should I
problem
get my
together.
calculator out?
I don't think you'll need it. Your mental math is usually pretty good, Ethan.
I don't know what 6 times 7 is.
Oh, come on.
42?
42.
Okay, so we pulled that.
And then 6 times the square root of 10 is?
60.
6 square root of 10.
Oh, sorry.
That's right. You were doing 6 times 10.
Yeah.
Okay. Okay, so that's the top. And then the bottom, Ethan, 7 times 7 is?
49.
Yeah. 49. And then we have 7 with the square root of 10, so write it next to each other. Negative square root of 10 with 7, so negative square root of 10. And then the last one, a minus 10. So the square roots cancel. Square root of 10 times the square root of 10 is just 10. And then there's a minus sign because you have a negative and a positive. So they were always canceled, those middle terms. It works because of the plus and the minus. So those two middle things should always cancel. They're going to be exactly the same, canceling each other out. 49 minus 10 is?
Yes,
39. Okay.
Oh, whoops, I accidentally multiplied this.
So here's the question, just like we did before. 42, 6, and 39. They're all the same type of numbers. They're all outside. They don't have square roots. They're not underneath square roots. They reduce by something.
3?
3. See, you didn't need a calculator.
Good
I
job,
was
Ethan.
thinking
42 divided by 3 is?
7.
14. 6 divided by 3 is? 2. 39 divided by 3 is? 13. Just 3 less than 42. So 42 is 14, 39 is going to be 13. Questions?
Is that the final answer?
That's the final answer. Not so bad when you go through it a second time.
What about the third?
All right, so what do you notice about letter D?
4 is.
They all consider divisible.
4, the square root of 4 is a perfect square.
2 plus 2 is 4.
2 plus 2.
3.
You get 3.
I feel so dumb right now.
Ethan literally thought he was so smart.
All right, so we're done with the notes part. I want to do a couple of homework problems with you because the bottom problems are a little challenging.
I know, Chelsea.
All right, so I want to do 2 problems with you, and then the rest of the period is yours. But just to kind of get you like a little bit of a head start. If you look at number 4 says the square root of 4 divided by 2 times the square root of 20. So what's one thing that you could do with this right now?
Simplify.
Simplify the 4. So the 4 becomes 2, and then Luke, what else can we do?
Oh, you can reduce the 2s.
If we reduce them, what number's left on top?
1.
1. Good.
Because I'm a genius.
Okay, so right now, the square root of 4 on the top became 2. And then we were able to cancel those 2's out. So we have 1 over the square root of 20. What else can we do to continue with the problem, Chelsea?
Break the square root of 20 down.
And it becomes?
2 times the square root.
Right, so the square root of 20 would be the square root of 4, the square root of 5. So now we have 1, and then 2 times the square root of 5. Any questions so far? So what would you multiply by to get the square root out of the denominator? Just the square root of 5, right. So you're only multiplying by the square root. That's the piece that we need to get rid of. The 2 in front, that's staying there. We're not using that extra 2. So Nina, the top now says
The square root of 5.
the square root of 5. On the bottom, the square root of 5 times the square root of 5 becomes 5, but there's already a 2 here, so 2 times 5 is
11.
10. Questions with that? There's a couple of problems that are similar to that.
Nope.
All right, then if you look at the bottom, and look at number 11. So if you go down to number 11. So number 11 gets a little trickier. What would we use to multiply with number 11?
Yeah, throw away those 2s. Like,
Can't throw away those 2's.
yeah, you can. Get rid of the negative.
So what are we going to multiply by? Not just the square root of 5. So there's 2 numbers down there. So Savannah, what would be the opposite of what's down on the bottom?
Plus negative 2 plus.
Right, negative 2 plus the square root of 5. So parentheses go around all of this, and then you got a lot of foiling to do. So just be really careful with the foiling.
That sounds absolutely
So 2 times negative 2 is negative 4. And then we have 2 times the square root of 5. Write them next to each other. My middle terms here, I have a negative square root of 3 and a negative square root of 2.
slow down. I'll fall behind you.
I'm just foiling. Does anybody know what the last 2 terms would be if I have a square root of 3 times a square root of 5?
Negative square root of 15.
Very good. Negative square root of 15. Okay, so the top is FOIL. There's nothing you're going to do with the top. Like, it's done. You FOILed it, you're done. You can't combine anything together. So see if you can FOIL the bottom. Get the square roots to cancel, and then you should just have a number left. So if we FOIL the bottom, we have negative 2 times negative 2. Negative 2 times the square root of 5. Remember, we just write them next to each other. Negative square root of 5 times negative 2 is positive 2 square root of 5, because a negative and a negative make a positive. And then what's negative square root of 5 times positive square root of 5? Negative 5. So these cancel. What number are you left with on the bottom? A negative 1. What happens when you divide by negative 1?
All the signs on the top change.
Yeah, everything on the top just changes. So my negative 4 is a positive 4. And then I have negative 2 square root of 5, negative 2 square root of 3, positive square root of 15. So you have about 10 minutes, which means that hopefully you can get a good head start on this. Stay where you are, no moving around. Just keep working as you are. I'm going to walk around and help.
Well, good thing I moved. That would have been not there.